Continental drift is the movement of the Earth's continents relative to each other by appearing to drift across the ocean bed. The speculation that continents might have drifted was first put forward by Abraham Ortelius in 1596. The concept was independently and more fully developed by Alfred Wegener in 1912, but his theory was rejected by some for lack of a mechanism and others because of prior theoretical commitments. The idea of continental drift has been subsumed by the theory of plate tectonics, which explains how the continents move. History. Early history: Abraham Ortelius, Theodore Christoph Lilienthal, Alexander von Humboldt, Antonio Snider Pellegrini, and others had noted earlier that the shapes of continents on opposite sides of the Atlantic Ocean seem to fit together. W. J. Keels described Ortelius' thoughts in this way. Abraham Ortelius in his work Thesaurus Geographicus suggested that the Americas were torn away from Europe and Africa by earthquakes and floods, and went on to say, the vestiges of the rupture reveal themselves, if someone brings forward a map of the world and considers carefully the coasts of the three continents. Writing in 1889, Alfred Russel Wallace remarks it was formerly a very general belief, even amongst geologists, that the great features of the Earth's surface, no less than the smaller ones, were subject to continual mutations, and that during the course of known geological time the continents and great oceans had again and again changed places with each other. He quotes Charles Lyell as saying continents, therefore, although permanent for whole geological epochs, shift their positions entirely in the course of ages, and claims that the first to throw doubt on this was James D. Dana in 1849. In his Manual of Geology, 1863, Dana says the continents and oceans had their general outline or form defined in earliest time. This has been proved with respect to North America from the position and distribution of the first beds of the Silurian, those of the Potsdam epoch, and this will probably prove to the case in primordial time with the other continents also. Dana was enormously influential in America. His Manual of Mineralogy is still in print in revised form, and the theory became known as permanence theory. This appeared to be confirmed by the exploration of the deep sea beds conducted by the Challenger expedition, 1872-6, which showed that contrary to expectation, land debris brought down by rivers to the ocean is deposited comparatively close to the shore in what is now known as the continental shelf. This suggested that the oceans were a permanent feature of the Earth's surface, and did not change places with the continents. Wegener and his predecessors. The hypothesis that the continents had once formed a single land mass before breaking apart and drifting to their present locations was first presented by Alfred Wegener to the German Geological Society on January 6, 1912. Although Wegener's theory was formed independently and was more complete than those of his predecessors, Wegener later credited a number of past authors with similar ideas: Franklin Coxworthy, Roberto Mantovani, William Henry Pickering and Frank Bursley Taylor. Eduard Suez had proposed a supercontinent Gondwana in 1858 and the Tethys Ocean in 1893, from a sunken land bridge/Josine Klein theory point of view, though. John Perry had written in 1895 paper proposing that the Earth's interior was fluid, and disagreeing with Lord Kelvin on the age of the Earth. For example, the similarity of southern continent geological formations had led Roberto Mantovani to conjecture in 1889 and 1909 that all the continents had once been joined into a supercontinent. Wegener noted the similarity of Mantovani's and his own maps of the former positions of the southern continents. Through volcanic activity due to thermal expansion, this continent broke and the new continents drifted away from each other because of further expansion of the rip zones, where the oceans now lie. This led Mantovani to propose an expanding Earth theory which has since been shown to be incorrect. Some sort of continental drift without expansion was proposed by Frank Bursley Taylor, who suggested in 1908 that the continents were dragged towards the equator by increased lunar gravity during the Cretaceous, thus forming the Himalayas and Alps on the southern faces. Wegener said that of all those theories, Taylor's, although not fully developed, had the most similarities to his own. Wegener was the first to use the phrase continental drift, and formally published the hypothesis that the continents had somehow drifted apart. Although he presented much evidence for continental drift, he was unable to provide a convincing explanation for the physical processes which might have caused this drift. His suggestion that the continents had been pulled apart by the centrifugal pseudo-force of the Earth's rotation or by a small component of astronomical precession was rejected as calculations showed that the force was not sufficient. The polefluct hypothesis was also studied by Paul Epstein in 1920 and found to be implausible. Evidence of continental drift. Evidence for the movement of continents on tectonic plates is now extensive. Similar plant and animal fossils are found around different continent shores, suggesting that they were once joined. The fossils of Mesosaurus, a freshwater reptile rather like a small crocodile, found both in Brazil and South Africa, are one example. Another is the discovery of fossils of the land reptile Lystrosaurus from rocks of the same age from locations in South America, Africa, and Antarctica. There is also living evidence the same animals being found on two continents. Some earthworm families are found in South America and Africa, for instance. The complementary arrangement of the facing sides of South America and Africa is obvious, but is a temporary coincidence. In millions of years, slab pull and ridge push, and other forces of tectonophysics will further separate and rotate those two continents. It was this temporary feature which inspired Wegener to study what he defined as continental drift, although he did not live to see his hypothesis become generally accepted. Widespread distribution of Permo-Carboniferous glacial sediments in South America, Africa, Madagascar, Arabia, India, Antarctica and Australia was one of the major pieces of evidence for the theory of continental drift. The continuity of glaciers, inferred from oriented glacial striations and deposits called tilides, suggested the existence of the supercontinent of Gondwana, which became a central element of the concept of continental drift. Striations indicated glacial flow away from the equator and toward the poles, in modern coordinates, and supported the idea that the southern continents had previously been in dramatically different locations, as well as contiguous with each other. Rejection of Wegener's theory. The theory of continental drift was not accepted for many years. One problem was that a plausible driving force was missing. And it did not help that Wegener was not a geologist. Other geologists also believed that the evidence that Wegener had provided was not sufficient. It is now accepted that the plates carrying the continents do move across the Earth's surface. Ironically, one of the chief outstanding questions is the one Wegener failed to resolve. What is the nature of the forces propelling the plates? The British geologist Arthur Holmes championed the theory of continental drift at a time when it was deeply unfashionable. He proposed in 1931 that the Earth's mantle contained convection cells that dissipated radioactive heat and moved the crust at the surface. His Principles of Physical Geology, ending with a chapter on continental drift, was published in 1944. David Attenborough, who attended university in the second half of the 1940s, recounted an incident illustrating its lack of acceptance then. I once asked one of my lecturers why he was not talking to us about continental drift and I was told, sneeringly, that if I could prove there was a force that could move continents, then he might think about it. The idea was moonshine, I was informed. Geological maps of the time showed huge land bridges spanning the Atlantic and Indian Oceans to account for the similarities of fauna and flora and the divisions of the Asian continent in the Permian era but failing to account for glaciation in India, Australia and South Africa. As late as 1953 just 5 years before Carey introduced the theory of plate tectonics the theory of continental drift was rejected by the physicist Digger on the following grounds. First, it had been shown that floating masses on a rotating geoid would collect at the equator, and stay there. This would explain one, but only one, mountain-building episode between any pair of continents. It failed to account for earlier orogenic episodes. Second, masses floating freely in a fluid substratum, like icebergs in the ocean, should be in isostatic equilibrium. Gravitational measurements were showing that many areas are not in isostatic equilibrium. Third, there was the problem of why some parts of the Earth's surface should have solidified while other parts were still fluid. Various attempts to explain this foundered on other difficulties. Geophysicist Jack Oliver is credited with providing seismologic evidence supporting plate tectonics, which encompassed and superseded continental drift with the article Seismology and the New Global Tectonics, published in 1968, using data collected from seismologic stations, including those he set up in the South Pacific. It is now known that there are two kinds of crust, continental crust and oceanic crust. Continental crust is inherently lighter and of a different composition to oceanic crust, but both kinds reside above a much deeper plastic mantle. Oceanic crust is created at spreading centers, and this, along with subduction, drives the system of plates in a chaotic manner, resulting in continuous orogeny and areas of isostatic imbalance. The theory of plate tectonics explains all this, including the movement of the continents, better than Wigner's theory. Bibliography, notes. References: Legrand, Homer Eugene, Drifting Continents and Shifting Theories, Cambridge University, ISBN A0-521-31105-5A. Oresks, Naomi, The Rejection of Continental Drift, Oxford University Press, ISBN A0-19-511732-8A. Oresks, Naomi, Continental Drift, in Munn, Ted. McCracken, Michael C. Perry, John S., Encyclopedia of Global Environmental Change, Volume 1, Chichester, West Sussex, John Wiley & Sons, ppA 321/325, ISBN A0-471-97796-9, OCLCA 633880622. Ortelius, Abraham, 1570, Thesaurus Geographicus, Antwerp, Plantin, OCLCA 214324616. Snyder Pellegrini, Antonio, La Croix Copyright Ashen Aces Mr. Res Dar Copyright Voila Copyright S, Paris. Frank and Densher. External links: A Brief Introduction to Plate Tectonics, based on the work of Alfred Wegener. Maps of continental drift, from the Precambrian to the future, observe an animation of the breakup of Pangaea, animation of continental drift for the last 150 million years, four main evidences of the continental drift theory, Wegener and his proofs.